Hi, and welcome to Prototype. We will be solving the problem for LeetCode 206 reverse linked list. This is another problem in the LeetCode 75 study plan. Let's get to it. Read the description. Given the head of a singly linked list, reverse the list and return the reversed list. Okay, in the example, they provide a linked list with 5 nodes, 1, 2, 3, 4, 5, and it wants us to return 5, 4, 3, 2, 1. Okay. Well, it's a linked list question, so why don't we do the basic setup? Let's make a dummy. We may or may not need the dummy, but hey, it doesn't hurt to have one. We can just remove this line later on. We'll need some sort of while loop. We could also use recursion to solve the problem, but again, I think the iterative solution with the trusty while loop just makes more intuitive sense. Hey, what are we doing at the end? We're going to return dummy.next. We'll need some sort of pointer to the head, and then typically we'd say, dummy.next is the head, something like this. And then we'll throw the current linked list node in the while loop for the Boolean expression while it's still not null, while it's a truthy value. Keep going. And then to traverse the linked list, we just call cur, we assign cur.next to cur. Okay. So let's think about this. What are we trying? How could we go about building the linked list 5, 4, 3, 2, 1? Well, what if we just simply traverse to the end, get to 5, and then start building from 5? So 5, we want to point to 4, 4, we want 4 to point to 3, 3 to 2, 2 to 1. Okay, that seems pretty intuitive. So why don't we start with that? Okay. What do we need? Well, we'll also need one more pointer to the previous node. So let's do that. Let's just set that to null. And once we get to the end, we'll need references back, right? So we could just create a doubly linked list. So let's do that. So the first prev will just be null because in a double linked list, we'll have 1 pointing to null, just like 5 points to null in its next reference. Okay. Previous will become cur. And then once we loop through all of this, we'll have a doubly linked list because we'll be adding the prev references to each node. Okay. Now, like I said, normally dummy.next would just be initialized to the head. We don't actually need to do that. We need dummy.next to initialize to prev. What is prev? At the end of this loop, so let's just start at 5. So we're at node 5. Cur.prev is prev, which is going to be 4. Prev becomes cur, so prev, which is 4, becomes 5, and then cur that becomes cur.next, which is null. Okay, so cur right now is null, and then prev is 5. That's why dummy.next will be initialized to 5. Okay, because 5 will be the head of the reverse linked list that we're trying to return. Okay, now let's reset our cur because, as I said, cur is null, so let's have cur equal to prev. We'll need another while loop, while cur, and then typically this would be cur is equal to cur.next, but we're currently at 5, right? Currently at 5, and then we need to traverse backwards. So instead of cur is equal to cur.next, we can just do cur is equal to cur.prev. Use the prev counter of the doubly linked list that we've created. And what are we trying to do? We're trying to build a list that builds from 5 to 4. So cur.next is equal to cur.prev because from 5 the prev is 4 and we want the next of 5 to be 4. Bam. And let's just run that. Okay, it passes. Submit. Boom. Not the fastest solution, as you can see, it's only 75.85%, and that's because this is a 2n solution, and because we're going to run through the all nodes in the linked list twice, doing it this way, And in terms of memory, it's also not the most efficient because we create a doubly linked list, which means that there's now twice the amount of references in there. All right. Why don't we try to see if there's a better solution? And to do that, when we're starting at 1, is there a way to start building the output, the reverse linked list from the first node? And the answer is there is, but how do we do that? Well, okay, so if we're at 1, okay, we visit 2, right? And then we have 2 point to 1. And then we move to 2. Move to 2. Okay? So now we move to 3. And we want 3 to point to 2. Okay? So we're kind of building this, you could say, backwards, right? Instead of building it forwards from 5 to 4 to 3 to 2 to 1 in the 2n solution, in the single loop solution, we need to build it backwards. So we're at 1, and we need 2 to point to 1, and then we need 3 to point to 2, okay? Until the end. All right. What do we do? Well, we'll need a while loop. We'll need a reference. We'll initialize cur to the head. While cur, so while cur is not null. How do we traverse? Cur is equal to cur.next. Again, dummy node, doesn't hurt. We can just delete it later if we don't need it. And in this case, we won't need it, but anyway. What are we returning? Dummy.next. All right, we'll need a previous reference again. The previous reference will be null. 1 points to null. Again, in the doubly linked list solution, the previous of 1 also points to null, right? Okay. Now, how do we do this? Well, okay, so what we need to do is we need to move to 2 so that we can have 2 point to 1. Okay? So the cur.next, right? So at 2, we want 2's next to be 1. Like that. Okay? And then now we need to move up. And the previous, in the first iteration, previous is null. Previous becomes 1. At the 2, the previous, which is 1, becomes the 2. So prev is equal to cur. Now this won't work because we're trying to say cur.next is prev. In the first iteration, prev is null. And then now we're saying cur is going to become null, and that'll break out of the loop. So what do we need? We need a temporary variable. The temporary variable, I would like to call temp. I think just contextually, what are we creating this variable for? It's just a temporary variable. But you could also call it next, because what do we need temp to hold? We need it to hold the cur.next reference. Okay? So now we can say to advance, right? Cur starts at 1, we need cur to become 2. So instead of cur equal cur.next, we need cur to be assigned to temp. Okay. Now let's run through this one more time. So we start at 1. We save the reference to the next. So we save 2. And now cur.next 1, instead of pointing to 2, will become pointing to null, right? And now move. So previously, the null reference becomes cur, which is 1. Okay, so we're at 1, and now cur traverses down to 2. Okay, cur traverses down to 2. All right. Now we want to save 3. We want 2 to point to 1. 1 prev is currently 1. And then after that, we move prev to the current. And then the current, right, moves to 3, moves to next. And then we run this until the end. Okay. And then at the very end, let's see what happens at 5. Okay, we save the next of 5, which is going to be null. Okay, cur.next is prev. Prev would have been 4, right? So 5 now points to 4. Prev becomes cur, which is 5, and then we advance cur to the next, which is null. Now that cur is null, we break out of the loop, and then what are we returning here? We need to return 5 because that's going to be the start of our new reverse linked list, and 5 is prev. Because again, in the last iteration, cur becomes the next reference, which is null. Prev doesn't get updated to null. Prev is 5. So we can just return 5. And like I said, we didn't actually need dummy in this case, but hey, linked list question, dummy node, while loop, return dummy.next, right? So run it, sanity check, submit. There we go. LeetCode doesn't seem to be much faster than the other one, but hey, that's LeetCode for you. All right, so that's the optimal solution to reverse linked list. LeetCode 206. Subscribe to see more. We'll be solving the rest of the LeetCode 75 study plan questions in short order. Thank you, and see you next time.